Greetings, boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary, and today we are going to work with equivalent fractions. Before we get into our lesson, we want to go over some of the vocabulary and just basically review what an equivalent fraction is. So let's talk about vocabulary. When you hear the word equivalent, I want you to think of the same as. Sometimes things can be the same as or have the same value of something, but it may not look the same. For example, I can represent the number 3 using different things. I can use my fingers. I can use the number 3. Although they both don't look the same, they hold the same value. So when you think about the word equivalent, I want you to think about the same value. Let's review our fractions. So we're going to begin by looking at 1 whole. Oftentimes, 1 whole will be referred to as 1. It is a whole number. Think of it as a cookie. This whole represents 1 cookie. It's not shaped like most cookies, so I like to refer to it as 1 whole candy bar or just 1 candy bar. The next fraction that we're going to take a look at are the halves. Right now, I have placed 1/2 under the whole. A half means you have taken a whole and you've broken it into 2 parts. One of those parts represents 1/2. When you join the 2 halves back together, you create 1 whole. So 2 halves is equivalent to or has the same value as 1 whole. When you think about the fraction 2 halves, it is written as 2 over 2. Now we're going to move into the fourths. They're called fourths because the whole candy bar has been broken into 4 equal sized parts. Speaking of breaking things into equal sized parts, when you're learning about or you're working with fractions, fractions are sections or equal sized partitions. So when we take a look at the fourths, one of the 4 parts is called a fourth or 1/4. Look at 2 fourths, and I'm going to remove one of the halves. What you will notice about 2 fourths is together, side by side, they have the same value or they are equivalent to one of our fraction pieces. Which fraction pieces is 2 fourths equivalent to? 1/2. Good job. So I want you guys to think about the size of these fractions and how sometimes when you combine them, they will be equivalent to other fractions together. So I'm going to go ahead and put this whole back. And we know that 2, well, let's not write this here. We'll write it here. We know that 2 fourths is equivalent to 1/2. And you don't have to memorize this. You have your fraction strips available. At any time, you are more than welcome to take a look at your fraction strips and use your X-ray vision to draw imaginary lines to align them. I would have drawn an imaginary line right here with my X-ray vision so that I can see that these 2 fourths has the same value as 1/2. Now let's move on with the fourths. In order to match the equivalency of 1 whole, you need 2 halves. But how many fourths do you need? You need 4. All 4 parts can join back together to create that whole candy bar that was broken into 4 equal sized parts. So 4 fourths is equal to 1. Which is greater in size? 2/4 or 4/4? Which is greater? 2/4 or 4/4? 4/4, because 4/4 is equivalent to 1. 2/4 is equivalent to half. Awesome. Okay, now we want to move into an even smaller fractional piece, an eighth. If a fourth is called a fourth because the whole has been broken into 4 equal sized parts, why do you think an eighth is called an eighth? Because the whole has been broken into 8 equal sized parts. Good job. I like to think of partitioning or dividing a whole into fractional pieces as sharing. With the fourths, I was sharing something with 4 people. With the eighths, how many people do you think I'm sharing with? 8 people. Excellent. So let's take a look at your eighths. We know that we have 8 eighths in one whole. Let's take a look at just 2 eighths. And we're going to draw an imaginary line here. 2 eighths is equal to or is equivalent to 1/4. And I'm going to drop this fourth down and bring 2 eighths up just to show you what I mean. The eighths are smaller pieces. Think of it as sharing a candy bar. If you're sharing it with just yourself and one person, you both get half. But when you begin to share it with more than just you and someone else, your pieces are going to get smaller and smaller because you have to keep breaking it. So the eighths are smaller in size than the fourths. That's why it takes 2 eighths to match the size of just 1/4. So let's continue. So now I'm going to add another eighth. How many eighths are on the board in this area? 4 eighths. Awesome. Great eagle eyes. So at this point, I want you guys to use your X-ray vision to draw a line down the middle where our half is. 4 eighths is half of all of the eighths that I have. I have 8 eighths in a whole. 4 of them is half. And you know what? 4 eighths is equivalent to my half fraction bar. Let's pull this out so that you can see it. I like to use the fraction strips to help me see how the fractions are equal or equivalent, because it helps me to see from end to end they match in size and length. Miss Owens, you said 4 eighths are equivalent to 1/2. Show me. Well, thank you for asking. I will show you right away. So that's 1/8, and I want to start on the end here. 2 eighths, 3 eighths, and 4 eighths. So let's review. How is it that 4 eighths is equivalent to 1/2? Why does it take 4 of the eighths to match the size of just 1 of the half? Yes, because the eighths are smaller in size. So it takes 4 of them to match the equivalent size of a half. So let's go back, put the half back. Even if you forget this, you can always use your imaginary X-ray vision, to draw imaginary lines on these fractions. So we know that 4 eighths is equivalent to 1/2. What happens when we get all 8 eighths up here? All 8 of them. They match the size of the whole. They are as long and as wide as the whole. So we know that 8/8 is equivalent to 1. Okay. And last but not least, we're going to move into the 16ths. If the fourths have 4 equal parts to make up that whole, and the eighths have 8 equal parts to make up the one whole, how many equal parts do you think the 16ths need to make up one equal whole? 16. Awesome. So let's go ahead and put some of the 16ths here. They're really small compared to the eighths. Why do you think the 16ths are smaller than the eighths? Think about equal sharing. Think about how many people I would share something with if I'm cutting it into 16ths. 16 people. Awesome. So the more you take that whole candy bar and you break it off to share it with more people, the smaller those pieces will get. Would you rather share your candy bar with yourself and someone else, cutting it in half? Or would you rather share it with yourself and 15 other people, making sizes of 16ths? I would pick a half too. I like candy, especially chocolate. Okay, so I want to take a minute to pause to show you that the 16ths are so small that if you do of them to match of 1/8. What do we call that word again? When the fractions have the same value or they take up the same amount of space? Equivalent. Awesome. So 2/16 are equivalent to 1/8. We're going to continue adding some 16ths here. How many 16ths do I have here? 4. Using my eyes to create an imaginary line here, I can see that these 4/16 are equivalent to 1/4. So 4/16 is equivalent to 1/4. And we're going to add more 16ths. One, 2, 3, 4, 5, 6, 7, 8. I have 8/16 up here. And I'm going to use my eyes to draw that imaginary line. I see that 8/16 is equivalent to 4/8. 8/16 has the same amount of space as 4/8. Drawing my imaginary line up. How many fourths is 8/16 equivalent to? It's also equivalent to 2/4. Drawing my imaginary line. How many halves is 8/16 equivalent to? Also equivalent to 1/2. So I'm going to go ahead and finish putting up the rest of these 16ths. And we know that it takes all 16 16ths to match the equivalency of one whole. So now that we've taken some time to review the basics, we're going to play a game involving equivalent fractions. It's called Uncover 2. Very similar to the game of Uncover. We'll get into the rules of this game, and it's a fun way to practice learning about equivalent fractions. So let's set up the game. If you don't have your fraction strips in front of you at this time, go ahead and grab those fraction strips and grab your workspace workbook because you're going to have a follow-up lesson, and we'll be ready to go. And something to write with. So we are going to play Uncover 2. Okay, let's begin with the rules of the game. So, the way you start this game is you're going to need the following fraction strips: a whole, your halves, your fourths, your eighths, your sixteenths, and you're going to need a fraction dice. So to start this game, you will take your halves and you will place them on top of your whole. You're going to cover it up. That's why in the game you will have to uncover. Okay? So, now, where did my whole go? It's behind the two halves. Tell me what you know about the equivalency of two halves, and one whole. Two wholes is equivalent to one half. Can you see it clearly now? Absolutely. Okay, so you roll the dice, and whatever the dice shows, let's talk about my dice. I have a side that has 1/8, two sides that have 1/8. You'll see a half on here, you will see a 16th, and there is a 4th. So you roll the dice, and whatever fraction shows up, that's the fraction that you uncover. What fraction do you see? 1/8. Do you see 1/8 on my fraction strip here? No, you do not. So at this point, I can exchange one of the pieces for other pieces that are equivalent to this. Now, I have to move 1/8, so I would probably put some eighths up here and then remove just one of them. But while you're doing this, you have to think about how many eighths would I need to match the equivalency of this half. Do you remember how many eighths? I would need 4/8. So I can take the 4/8 and I would cover up the fraction strip with the 4/8. The goal of the game is to uncover or take off whatever you roll on the dice. But if you roll something on the dice and it's not up there, you can exchange fractions to make what you rolled. So while I'm doing that, I'm just going to take a note. I'm going to take note of all of my equivalent fractions. So I know that 1/2 is equivalent to how many eighths? How many eighths did I exchange for that 1/2? 4/8. Okay? And I am going to remove one of those eighths and put my piece here. Now, if I'm playing this game with a partner, the first person, my partner would have their strips and I would have my strips. And we would both roll the dice and take turns. And when I'm finished, I would say, done. And then my partner would roll the dice and try to remove or exchange. And then when he's finished, he would say, done. And I would check to make sure his fraction tiles are lined up properly. If his fraction tile is hanging off like that, then I'm going to say, you need to align your fractions correctly. They need to be evenly aligned so that we can keep reinforcing the fact that in order for two fractions to be equivalent, they must be evenly aligned and they must cover the same amount of space. Okay, so because I'm playing by myself, I'm just going to continue playing. So I removed one of my eighth pieces, and now it's my time, and I recorded my equivalent fractions. Now it's my time to roll the dice again, and I'm just going to write my little title here, equivalent fractions. And so far I found 1. Okay, so when I rolled the dice, which fraction did I roll? I rolled 1/8. So I am going to uncover. I'm going to uncover here. Now, how much of my fraction, how much of my whole have I uncovered? I uncovered 2/8 so far. I uncovered 2/8. How much of my fraction is still covered up? I have 1/2 and I have 2/8. So let's keep playing. Which fraction did I roll? 1/16. Do I have any 16ths up here? No, I do not. So I am going to exchange the 16ths for one of my pieces. Miss Owens, I want to exchange the 16ths for the half. You do? You're going to be stuck with a lot of pieces up here. The goal is for me to remove the pieces as I roll them. If I put 16ths on the half, it would take 8 16ths. That's going to be more pieces that I will have to take off. So I'm going to trade out the 16ths for an 1/8. How many 16ths is equivalent to 1/8? 2 16ths. And I match them up underneath like this so that I can make sure that they are equivalent. And I would tell my partner, done. And my partner would agree, yes, you found the correct equivalent fractions. And I'm going to put them up here to cover up and take the place of that 1/8. Write my equivalent fraction. 2 16ths is equivalent to 1/8. And I get to move one of the 16ths because that's what I was supposed to move. Rolling again. Which fraction am I going to uncover? 1/8. Good job. And I can just take this down because I have it up there. I'm just going to slide this over. How much of my fraction, how much of my whole is still covered up? More than half, because I have half covered and a 16th. How many 16ths is in this half or is equivalent to the half? Imaginary line with your X-ray vision. Doody 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 doody. 1, 2, 3, 4, 5, 6, 7, 8. 8 16ths is equivalent to half. So if this is equivalent to 8 16ths and there's one more 16, 8 16ths and 1 16th. How many 16ths would that be together? 8 16ths and then one more. 9 16ths. Awesome. So 9 16ths of my whole is still covered. And I would need 16 16ths to get the whole thing. So this represents 9 of the 16ths. How many more would be left that's uncovered? 9 16ths plus how many 16ths equals 16? 9 plus what number equals 16? 9, 10, 11, 12, 13, 14, 15, 16. 7 16ths are still uncovered. Okie doke, we're doing wonderful. Let's roll that dice. It's my lucky day. What am I uncovering here? I am uncovering 1 16th. How much of my whole is uncovered? Meaning I have taken it off and I can see the blue. Half of it is uncovered. How much is still covered? Half of it is still covered. Let's do a little fraction trivia. How many fourths is equal to that half? 2 fourths is equivalent to half. How many eighths is equivalent to that half? 4/8. Are you using your x-ray vision to draw an imaginary line? Of course you are, because you're fabulous. How many 16ths are equivalent to the half? 8/16. Oh, please be half, please be half, please be half. Now at this point, when I get ready to roll the dice, if it's half, I'm just gonna uncover that last one. And the game will be finished. And if I finish uncovering my whole before my partner does, I won. But if it's not half, then I'm going to have to exchange that half out for some fractions. So please be half, please be half, please, please, please. Womp, womp, womp. I rolled the 16th. Well, boys and girls, we are out of time. This is the end of our lesson. I hope you guys have enjoyed this game, and I hope you've learned more about equivalent fractions. Keep giving it your best, and I know you guys can do it. Following this video, you guys are going to work in your workspace book, and I believe it is page 11 for this lesson. Thank you guys for tuning in, and I will see you next time.